I'm hoping to tell you some stuff that is not familiar to you about St. Thomas and Kepler. I'm going to start off with just an image from a New American Bible, right? People here who may have a New American Bible, people from other places in the world, maybe this image isn't as common, but in the United States, when I was in grade school, they gave us a Bible. It was a New American Bible, and it had this picture in it. And this is the world of the Hebrews, right here, right? And it has the picture of wrong button. It's got the dome of the sky, it's got the earth below, and it's got the celestial lights up in the heavens. And so in Genesis, it reads, "And God said, let there be lights made in the firmament of the heaven to divide the day and the night, and let them be for signs and for seasons and for days and years, to shine in the firmament of heaven and to give light upon the earth. And it was so done. And God made two great lights, a greater light to rule the day, and a lesser light to rule the night, and the stars." All right, so here we're looking at the firmament of the sky, okay, and we've got an observer there. Well, he's in the middle, all right, or she. Okay, so greater and lesser lights. So you look up at the night sky, all right, and you see the sun, the moon, and the stars. And the sun and the moon and the stars all have, different sizes, okay? The sun and the moon are larger, as we see in this. And I think I've just lost that laser. So let me see if I get, the star, so the sun and the moon here, and the stars. Stars appear smaller. So if we imagine that the sun and the moon and the stars are all on a dome of the sky, then everything is just as it looks. The sun and the moon are bigger. They look bigger, they are bigger. The stars look smaller, they are smaller. But now I'm just going to look at the moon and the stars, because you don't see the sun and the stars together at the same time. So just looking at the moon and the stars here. Well, the thing is that if I look at the geometry of this, and I push that star so that it's further away, okay, then if the star is further away, then that means that it is bigger than it seems, okay, because of the effect of distance, right? So when I'm sitting here looking out at people in the audience, okay, the further away you are, the smaller you look to me, okay? So folks sitting up there, that lady's head is smaller than the nail of my little finger. All right, Father Davenport here, I can't even cover I cover his eyeball with my little finger. Okay, so, to have someone sitting in the back and have their head look as big as Father Davenport's, that'd have to be pretty big. Okay, so the further away something is, if it looks to be of a certain size, the further away it is, the larger it has to be. So if I imagine making that star further away still, okay, then it'd have to be about equal to the size of the moon, all right? Now, throughout history, when astronomers measure how big do the stars look, you look up at the moon, and everybody says, and they will say today, if you ask someone who doesn't, well, not an astronomer, but if you ask a person who doesn't know much about astronomy today, how many stars would it take to fit across the diameter of the moon? Okay, they'll give you about the same answer that astronomers have historically given, which is 20, 30, 10, right? But somewhere in that number, 20, give or take 10. It's not you're not making a precise estimate. But if you have somebody who can, especially someone who can eyeball things pretty well, they'll tell you, 20 roughly. And this is what astronomers throughout history have typically said, that a star is about roughly, ballpark figure, a 20th the apparent size of the moon. What if you made the star even further away? Okay, if you made the star further away, then it would have to be larger than the moon. And if you made the star further away still, then it would have to be much larger than the moon. Now, Ptolemy, in the Almagest, which is roughly 150 AD, says, now, that the Earth has sensibly the ratio of a point to its distance from the sphere of the so-called fixed stars gets great support from the fact that in all parts of the Earth, the sizes and angular distances, notice sizes of the stars at the same times appear everywhere equal and alike. For the observations of the same stars in the same different latitudes are not found to differ in the least. All right, so what's this saying? Well, imagine that the stars are relatively close to the Earth. Then, so here I got two stars, and I have two different observers on the surface of the Earth. Okay, this observer is closer to the stars than this observer is. So the observer, say this is on the equator and this is up toward the Arctic. Then the observer on the equator being closer to the stars than the observer at the Arctic is going to say that those two stars, A, appear dimmer. The person on the equator will say they appear brighter. The person up by the Arctic will say they appear dimmer. The person at the equator is going to say that the stars appear larger because they're closer, right? Just as the further I back away from Father Davenport, the smaller his head looks compared to the size of my finger. Okay? And the two stars will appear closer together for the person at the Arctic than for the person at the equator. That is because the distance will change the intensity of light, the apparent size of the stars, and the separation of the stars. And this is what Ptolemy is saying, okay? The sizes and angular distances, we talk about the distances between the stars, appear everywhere equal and alike. Observations of the same stars in the different latitudes are not found to differ in the least. So how do you solve the problem of the fact that everybody on the Earth sees the stars as having the same sizes, brightnesses, separations, yada, yada, yada? You make the Earth little. If the Earth is very small, then everybody's going to see the same thing because they're all the same distances away from the stars. Okay. So now the person on the equator agrees with the person at high latitudes, right? So this is what Ptolemy is saying. Obviously, the Earth is a point. Okay, you can measure this as precisely as you wish. Get out your measuring instruments, your calipers, your protractors. You make big ones for measuring the sky. But you make these measurements as precisely as you want. At different latitudes, you can see no difference. And Ptolemy concludes that the Earth is vanishingly small compared to the distances of the stars. Now, here we see Saint Severinus Boethius On the Constellation of Philosophy, roughly 525 AD. You have learned from Ptolemy that this globe of Earth is but as a point in respect to the vast extent of the heavens. That is, the immensity of the celestial sphere is such that ours, when compared with it, is as nothing and vanishes. All right. So this is a Christian writer. Ptolemy's argument is highly persuasive. Okay, nobody's going to say, oh, no, that's not true, right? It's not too hard to figure out, contrary to, what you hear, in science shows once in a while about, how the pre-modern view of the universe was comfortably small and cozy and blah, blah, blah. All right, that's not true. Okay, the universe has always been huge compared to the Earth, as long as anyone has bothered to put a lot of time and effort into measuring things. So, if the Earth, according to Ptolemy, has sensibly the ratio of a point to its distance from the sphere of the stars, then it follows that a star is way, way, way bigger than the moon. Okay, this is showing a star and the moon according to Ptolemy's estimates. All right, so that diagram isn't just, I didn't just make that up for throwing some in. That's actually some number. Those sizes, the little brown one, that's the moon, and the big red one, that's a star, according to Ptolemy's size estimates. Okay. Now, you'll find this sort of size estimate all throughout history up until the Copernican revolution. Christopher Clavius is, I guess he's arguably sort of one of the last great, he's after Copernicus, but he's follows Ptolemaic astronomy. And he has a whole listing of sizes. And the moon is like the smallest thing, maybe Mercury. Okay, the moon and Mercury are the smallest objects in the universe. Right. My point here being that no one's arguing about this. Everybody is accepting this idea. So therefore, Genesis says that the moon is one of the two great lights in the heavens, and astronomy says the moon is the smallest of lights in the heavens. Obviously, we have a serious Bible science conflict. Okay. So, what does St. Thomas have to say about this? All right. He says, so what? Okay. He said, this is in question 70. As Chrysostom says, I haven't been able to find Chrysostom saying this. I've looked, but this is not my area. So if someone here knows this, I would love to know where is it that Chrysostom says this. As Chrysostom says, the two lights are called great, not so much with regard to their dimensions as to their influence and power. For though the stars be of greater bulk than the moon, yet the influence of the moon is more perceptible to the senses in this lower world. Moreover, as far as the senses are concerned, its apparent size is greater. By the way, I chose Aquinas for obvious reasons, okay? But Augustine also says this in the literal meaning of Genesis. So, what St. Thomas is saying is that Genesis is describing the world seen by our eyes, right? It's describing the world seen by our eyes. It is not a science book that is giving us a scientific description of the moon and stars. And nobody argues about this. In fact, there's an excellent discussion of this by John Calvin in his commentary on Genesis, which he goes on, he just tees off on this subject. It's a fascinating read, and I encourage you to look it up and read it, because he says the same thing that Augustine and Aquinas says, but he's so much more animated about it. And he said, and he goes on and on and on. And I just have a bit of it that I've saved here, that Moses in Genesis, this is Calvin, makes two great luminaries, but astronomers prove otherwise. Astronomy is not only pleasant, but also very useful to be known. It cannot be denied that this art unfolds the admirable wisdom of God. Ingenious men are to be honored. Those of you all who are astronomers here, ingenious men are to be honored who have expended useful labor on this subject. Moses, therefore, rather adapts his discourse to common usage. There is therefore no reason why janglers should deride the unskillfulness of Moses in making the moon the second luminary. For he does not call us up into heaven. He only proposes things which lie open before our eyes. Which is the same thing as St. Thomas said. But this itself, this discussion is considerably longer and more animated, and I've edited it down. So he really goes on. And then he does another discussion on the Psalms, where he goes back and hits the same topic. I can't remember off the top of my head which psalm it is that speaks of the two great lights. But he once again is like, and once again, blah, blah, blah. It's a great discussion. So my point here is twofold. This does have something to do with Copernicus, but I'll get to that. All right. But one thing is that in the webpage for this conference, it talked about the Copernicus representing the first big interaction between astronomy and Catholic theology. And I would argue that that's not correct. Okay. Here we have a significant interaction between astronomy and Catholic theology that well dates Copernicus. It's also noteworthy in that it is devoid of controversy, which is probably why we think that Copernicus is the first significant interaction. But Ptolemy and Augustine and Aquinas, those are all significant figures. You can't get a lot more significant than that. Okay, so let's go to Copernicus. Many centuries later. So Copernicus is not, the issue with the Copernican theory has to do with the Earth's motion, where the situation is not this one of Ptolemy, where we say, hey, people at two different points on Earth's surface, they see the stars the same, so we have to figure the Earth has to be really small by comparison. The situation is this, right? If the Earth is going around the sun, then people at two different positions in the Earth's orbit should see the stars differently. The same argument about Earth under Ptolemy becomes about the Earth's orbit under Copernicus. It's not that you can move from one place to another on the surface of the Earth and find there's no change in how the stars appear, but rather that you can move from one place from Earth's orbit to another. In other words, and since we're all moving in the Copernican theory, this is a really easy thing to do. Okay, to test Ptolemy requires that you coordinate astronomers over significantly different latitudes. Okay, but you yourself from or you have to travel a significant distance. But you yourself can observe this by just observing and then waiting a few months, okay? And Earth will carry you around to a different point on its orbit, and then you observe again and see what happens. It's very easy to test. So under the Copernican theory, at one time of the year, the stars should look brighter. And then as the Earth moves around in its orbit away from those stars, it should look dimmer. And by the time you get way the heck over here, they should look a lot dimmer. And they should look smaller too. And they should look closer together. Okay. That going, again, to keep picking on Father Davenport, because he was unfortunate enough to have chosen to sit right in front of me, that not only is it that his head looks smaller as I get further away, but his eyes are closer together too. Okay, so not only the size, but the angular separation. What's the solution to this problem? Make the orbit of Earth little by comparison to the distance of stars. One of the problems that we have in visualizing this is that we always talk about Copernicus moving the stars further away, okay? Which gets the idea that we think about the stars being the stars and then we just move them out. Like we take some tennis balls and like spread them out further, okay? That it's very easy that way to forget about what moving things out has to do to their sizes, okay? So there is an astronomer who I've studied, who's, because I'm up in front of a bunch of people, I'm free. My brain is freezing. Taquet, okay. Robert Hooke refers to Giovanni Battista Riccioli and Andreas Taquet as great anti-Copernicans. And Taquet gives an analysis of the Copernican system, and he speaks that what Copernicus does is shrinks stuff, okay? You take the Earth and you shrink it down. The Earth's orbit becomes your baseline for observations, not the Earth. So you're shrinking the solar system, okay? Copernicus doesn't make the universe bigger. He makes the solar system smaller, is what Taquet says. And it's easier to imagine when, if we're making the solar system smaller, then what does that mean for the size of the solar system against the sizes of those stars? Okay, it's easier to think about. And then Taquet says, Galileo never figures this out. Okay. Your solution is the same. The stars are far away. Okay. Now they're far away, not compared to the Earth's size. They are far away compared to Earth's orbit. Make the Earth's orbit a point instead of the Earth being a point. And you've got eliminated this problem of people that your observations won't agree at different points in Earth's orbit. Make the Earth's orbit a point. Boom, problem solved. Now the stars are going to look the same regardless of where you are on the Earth's orbit. The problem with this is that it makes the stars huge. Okay, the stars have to be huge. So Riccioli does some calculations on his observations. It turns out that a typical star in the Copernican system has to be bigger than the entire Ptolemaic universe, right? If you wonder, why do people not like the Copernican theory? It's because it turned the stars into bodies bigger than they thought the universe used to be. Okay, maybe the Tycho Brahe universe, the geocentric universe. Okay, I know this because this is my area of research. This is where I go and I dig out, old books on astronomy, and I read this stinking scientific Latin, which is a major pain in the rear. Okay, to labor through that stuff and figure out what the heck are these guys saying, and this is what they all say. Now, Johannes Kepler. The nice thing, the fun thing is that you talk about this, and you talk about Giovanni Battista Riccioli and stuff like that. People say, "Oh, who's he?" Oh, he's one of those, he's one of those people who rejected the Copernican theory. But what's really great is that Johannes Kepler says this too. Okay. Kepler says, "Oh, the stars are huge. They have to be because they're so far away, and how would we be able to see them? Based on their sizes." And the other thing Kepler says is they're so dim. The stars are dim. Okay. Why are the stars dim? Because otherwise, if they weren't dim, they'd light up the night sky. Okay. The sun illuminates the sky fantastically, obviously, but even the moon, you got a full moon. You can see a lot by the full moon. Have no full moon, have no moon at all. What do you see? Dark. Okay. Kepler says the difference between the sun and the stars is practically infinite. This is despite the fact, he says, that if you took all the stars, you look at all the stars and you look at their measured sizes, and if you gathered them all together into a ball in the sky, clumped them all together, they would be similar to the sun in size. The total size of all the stars gathered together would rival the sun. And then Kepler says, and what's so great about this is he's talking about Galileo's discovery. He says, Galileo, with your telescope, you've discovered that there's thousands more stars we didn't even know about. So this just means I'm even more right than I thought I was. Okay, because if you took all your extra stars that you found with the telescope Galileo and added them to the clump, that make something even bigger. So this shows us that the stars are even dimmer. The difference, he says, is practically infinite between a star and the sun. And so therefore the stars are ridiculous. They're dim, dim, dim. They're huge. They're dim. Okay. Otherwise, they light up the night sky. And Kepler says, and science proves this. Any idiot astronomer can go out, make the measurements, do the calculations, and will get my results. So here is what the universe looks like. There's the sun, very bright, very small. There's the stars, big, dim. I want you to notice the little graphic. See here, when I switch to this, notice we've got these stars here. Those are shiny stars. But now we're going to Kepler. See, dim stars, right? Technology is wonderful. So, bright, shiny sun, huge, dim stars. Okay. Now, these stars in this picture are nowhere near far enough away, and they're nowhere near big enough. Okay, to really be realistic. It just gives the idea. But what Kepler is saying, Kepler says, our sun is more splendid than the fixed stars. In fact, our sun is more splendid than the fixed stars all combined. This is from the Conversation with Galileo's Starry Messenger of 1610. Kepler says this is a wonderful universe. Right? Now, I'm paraphrasing here. If I have time, I'll give you the full quote later. Right? God has demonstrated power by creating the giant stars. But God has demonstrated love for the least things through the care put into creating the brilliant little sun, this littler earth, and we littlest things on it. This is from his De Stella Nova of 1606. That's a paraphrase and very shortened. And this is the universe that science demands. You must accept, if you're going to be scientific, you must accept this view of the universe, is what Kepler says. Okay. So if we want to talk about a scientific reception of the Copernican system, a scientific reception of the Copernican system is one that acknowledges the star size question. Okay. You can be like Kepler and say stars are huge in the Copernican system. Isn't that cool? Right? Or you can be like Riccioli and pretty much everybody else who argued against the Copernican system, who had sense, right? Who was an, I don't want to sound like a real snot here, but who was an astronomer and knew what they were talking about. All right, who actually knew what the night sky looked like, knew what the measurements were, knew the basic geometry. The alternative was to say that that in the Copernican system the stars were huge, and isn't that stupid? Okay, to say that the Copernican system, in order to solve this problem about how come the stars look the same as the Earth goes around the sun, jumps through these crazy hoops and turns the stars. It has, like you have this major problem that the stars look the same no matter where Earth is in its orbit around the sun. That is a major scientific argument against the Copernican system. And so how do you solve that? Oh, we'll put the stars really far away, and that makes them huge. Okay, and that's an ad hoc solution to a scientific problem. And that's a bad solution. And the much better, more elegant solution, is what Riccioli says, is don't make the stars far away. In order to do that, don't make the Earth move. Okay. The more elegant solution is to have the Earth at rest. And then you can have stars that are located just past Saturn. And since, for those of you, a quick show of hands, how many people look up in the sky and can point Saturn out with their finger and their two bare eyes? One. Okay, yeah, that's a thing. Okay, it's hard to understand this if you don't know what the sky looks like. But you go out and you look up at the sky, you've all seen Saturn, you just don't know it. Okay, Jupiter and Venus, like how many people have seen Venus with their own two eyes? See, because Venus is bright. Okay, but Saturn looks like every other star. Okay, so if Saturn looks like every other star, and the geocentric idea was that the stars were located just past Saturn, then a star looks like Saturn, it's basically at the same distance as Saturn, and therefore it's going to be the same size as Saturn. Reasonable size, geocentric system. Stars are about the same size as Saturn. Heliocentric system, stars are bigger than the universe. Okay, therefore, heliocentric system stinks. That's Riccioli's argument. That's a scientific reception of the Copernican system. You can take Riccioli or you can take Kepler. But the other stuff that you hear about, okay, that somehow the Copernican system represents our view of the universe, that's not true from a scientific perspective. Someone who didn't understand what the sky looked like might think otherwise. Okay, but Kepler is a very good scientist. Now you might be saying to yourself, wait a minute. The stars aren't huge and dim. So how can this be science? Okay, this is all wrong. Well, you know that now, thanks to a couple more centuries of astronomy. All right, they didn't know that then. You see, when you look up at the sky and you see the different sizes of things, the size of the moon and the sun that you see up there, that actually represents the physical size of the moon and the sun. Okay, you are seeing the moon, the body of the moon, when you look at the moon, and when you look at the sun, which is best not to just do in the middle of the day, but you look at a sunset, you see the ball of the sun. You are seeing the globe of the sun. You see the globe of the moon. Those sizes are real that you're seeing. Not with the stars. Okay, so keep an eye on the clock here. How is it that this can be science? That star sizes, whether they are seen by the eye or the telescope, are false. And that greatly exaggerates their size. Okay, when you see a size of a star, you're seeing basically an illusion, an artifact of optics. When you look at the setting sun, you're seeing the globe of the sun. You see the moon, you're seeing the globe of the moon. You see the dot of light up there, that's a star. That's not the globe, that's not the body. Okay, that's just the light that we now know, because astronomers had to fight this subject out over a long period of time. That's caused by a phenomenon called diffraction. It's caused with the naked eye, it's atmospheric effects, et cetera, can all go technical discussion. But even when you're looking at photographs taken through telescopes and you see the little dots that are the stars, those are all false. Okay. Jonathan, we've got, what star has actually been directly, a few of them have been directly imaged. Yeah, but I mean, pretty much, but every picture of a star that you've seen is the dot you're looking at is false. Okay, it's an artifact of light, of photography, and so on and so forth. Okay. Now that holds true for the planets too. When you're looking up with your naked eye. Okay, the dot sizes, the sizes the planets look, same thing. And the devilish thing is that when you get out a small telescope like Galileo used, then the telescope shows the planets, their globes, as they really are. So when you see and it shows the stars false, which misled. That's a really difficult problem. Okay, but that is why in Kepler and Galileo, nobody understood this until into the latter part of the 17th century. They didn't even know. Latter part of the 17th century, it's not that they understood it. They began to realize they could maybe have a problem. Maybe. But some people didn't think so. So Kepler says that this is the science demands, so we're going to forget our little modern knowledge now. We've got to go back and put our heads back on as 17th century people. So forget that I gave you that explanation. So this is, given the data available to Kepler, Galileo, Copernicus, Ptolemy, things like that, this is the universe that science demands if you're going to think the universe is Copernican. So the scientific reception of the Copernican system is one that acknowledges the star size question. So, for example, here is a quote. This is from Melchior Inkofer, S.J. He's a member of the Special Commission to investigate the dialogue set up by Pope Urban VIII, the dialogue of Galileo. In his Tractatus Synopticus of 1633, the defenders of the Copernican system imagine that the stars have a size which is explicable by hardly any proportion. Okay. The Copernican system requires giant stars. So, if you're talking about Copernicus, Christopher Clavius, Johannes Kepler, Christoph Scheiner, Jesuit astronomer who argued with Galileo over sunspots, also did a lot of other interesting things. Galileo, Bellarmine, Pope Urban VIII, etc. If you're talking about, scientifically speaking, what does the Copernican system look like? This is what the Copernican system looks like. So, for this talk, there's 2 points that I would like you to remember. Right? First is St. Thomas, who is accepting science even if it contradicts Scripture. This is regarding the moon, the stars, and Genesis. Right? And the second is Kepler, who is being right about the science, but the science is not right in regards to the sun and stars. And it's the same thing for both of them, right? What St. Thomas is talking about, the link here is that they're both basing their ideas on observations of the same stuff. So, hang on a minute, I'm getting low. I didn't think I'd need this sweater. I do. Father Tabachek, remember the air conditioner? So, the interesting thing that we have here is that St. Thomas and St. Augustine and Calvin, they were all willing to accommodate Scripture to scientific discovery, right? They had no trouble with it. And they did. And the science that they accommodated was wrong, okay? The stars were not, okay, so yes, today we understand stars are bigger than the moon. Okay, this doesn't stand out to us because their answer was right, even though their method was wrong. Okay, but they were still wrong. The Ptolemy was wrong because Ptolemy's estimation of the sizes of stars was wrong. So they accommodated Scripture to wrong science. Had the stars, because of the way the optics work, had the stars been 1/10 the size of the moon, but they still put out the same amount of light as they do, they would still look the same way, okay, because you're not seeing their actual sizes. So it could have been in a different sort of universe that scientists would later come around and find out that, and say, oh, no, stars are actually smaller than the moon. Okay, now that did not happen, so we don't notice that the wrongness, the fact that major church theologians agreed that we need to agree with what the science says, and we go along with that, and we say, well, we interpret Scripture in light of the science, but the science actually turned out to be wrong. We don't notice that because the answer came out to be the same. And then on the other hand, we have Kepler, who was right, Everything Kepler did, if you were a scientist in 1606 or 1610, and you made those measurements and you did the calculations, you would get exactly the result that Kepler did. His things were what we call in science reproducible completely. Okay, so he was completely right, but the science wasn't right because they didn't understand the optics of of star sizes. So what was new? The new universe, right, was old. We had the new and the old had the same issues. Now, my check says I still got about 15 minutes, right? Okay. Now, I want to have plenty of time for questions that people haven't, so I can. Okay. All right. Okay, so let's go back to the idea that Kepler says, that this is the universe science demands. But Kepler says this, more or less, okay? But Kepler says everyone wants this universe, okay? This is the universe science demands. This is the universe that Giordano Bruno, okay, well, I'm here, I have to make sure I go down to the Campo di Fiore to see the statue, okay? But Giordano Bruno is famous for the idea that, the sun, the stars are other suns, and they're surrounded by other Earths, and those Earths have people on them, et cetera, et cetera, et cetera. Okay. Bruno says this, and Kepler is very much in his discussion, in his conversation with it's called Conversation. It was written in his discourse on the Galileo Starry Messenger. Kepler specifically calls out Bruno that, and he points out the differences about the sizes of stars and stuff like that. And he specifically points out to say, this is to show Bruno is wrong. The stars are not other suns. Okay. But everybody wants the stars to be other suns. It's such a cool idea, right, to have other suns. Because, stars are suns. And then if there's other suns, then the sun has an Earth, so the stars have other Earths, and Earth has people, and so they're going to have people. So you got the whole thing. You got other stars, other Earths, and other intelligent life. And, the next thing you know is you have blockbuster movies with invading aliens, and you're making millions of dollars, okay? Because it's such a great story. Right? But I would say that Kepler would go and say, well, that's the unscientific reception of Copernicus. Okay, is to think that Copernicus involves a universe of other stars other suns. And I think that Kepler would say, well, how's that worked out for you? Okay. Now, if I would build on Kepler's ideas, think that Kepler would say that, he said it's a wonderful universe. And I think that Kepler would be sort of pleased to say, okay, if you brought Kepler here, I think Kepler would say, the universe that you've discovered in the 21st century is not exactly what science revealed in my time. However, it would seem to be more like what I, Kepler, saw than what Bruno imagined. So in that sense, what is new is also old again. Okay, Kepler really, I can't emphasize how much Kepler really did not like Bruno's ideas. And oftentimes you read about Kepler and they'll say something to the effect, Kepler couldn't bring himself to accept Kepler was vehemently arguing that Bruno's ideas didn't conform to science. Okay, Bruno didn't know what he was talking about. And Kepler really was adamant about this, and it was all because of the sizes of the stars and the dimness. Kepler talks about if you go and have a dark room and you take a pin and poke have a pinhole in the roof, that the light that comes from the sun through that pinhole immediately overwhelms all the lights of the stars together. And you can do some basic little calculations about this, and you see that Kepler is absolutely right. that you can imagine, like in this room, if we could blacken the room, we could have the smallest hole you could imagine being able to drill and actually drill, something's actually doable. And then calculate if the disk of the sun is behind that hole, how much light radiation is coming through that hole, and you compare it to what you get from the stars. And it's huge. It's gazillions. I got it somewhere if somebody really wants to know. But Kepler was right. It is essentially, it is like to infinite. Okay, so Kepler, I think, would also add that, I was certain, Kepler would say, I was certain that Jupiter would have been inhabited at least. Okay, Kepler was not opposed to the idea of life on other worlds, all right? He was just opposed to Bruno's ideas. And Kepler speculated on how Jupiter would have life on it because, well, it's got these 4 moons and it'd be great for navigational purposes and stuff like that. And it'd be so useful. So obviously, he had this whole idea that Jupiter had these moons to help compensate for the fact that it was further from the sun. So I think Kepler would say, who would have thought that life and worlds like Earth would be so elusive? And I think he would argue that we should beware of what we think that we know. And I think that Kepler would say that it is all the more clear that God has demonstrated love for the least things through the care put into creating this littler Earth and we littlest things on it, considering that such worlds seem to be rather rare, which I think Kepler would take great satisfaction in, considering his ideas about Bruno. So I have the time, so I'm going to give you the full Kepler quote. This is what he says in his new star of 1606. And this is after he goes through a calculation showing the sizes of the stars and how huge they are but then he says, and so I've been paraphrasing Kepler before, but this is actually his words translated, of course, he wrote in Latin. Where magnitude waxes, there perfection wanes, and nobility follows diminution in bulk. The sphere of the fixed stars, according to Copernicus, is surely very large, but it is inert, without motion. The movable world, that's the solar system area, is next. Now this, all the more divine as it is smaller, has taken on motion that is admirable as it is well ordered. Nevertheless, that place neither contains a nutritive faculty, nor does it reason or discourse. What it does when moved, it did not learn, but it retains what was impressed upon it from the beginning. What it is not, it will never be. What it is was not made by it. The same thing endures that was created. Then comes this, our little ball, the little cottage of us all, which we call the earth, the womb of the growing, herself informed by a certain internal faculty. The architect of marvelous works, she kindles daily so many little living things from herself, plants, fishes, insects, as she may easily scorn the rest of the bulk in view of this, her nobility. Lastly, behold, if you will, the little bodies that we call the animals. What, in comparison to the universe, can be imagined that is smaller than these? But there now behold feeling and voluntary motions and infinite architecture of bodies. Behold, if you will, among those, the animals, these fine bits of dust which are called men, to whom the Creator has granted such that in a certain way they may beget themselves, clothe themselves, arm themselves, teach themselves infinite arts, and daily work toward the better, in whom is the image of God, who are in certain way lords of the whole bulk. And who among us would choose a body the breadth of the universe in exchange for no soul? Let us learn, therefore, what well pleases the Creator, who is the author of both coarse bulks and minute perfections. For he glories not in bulk, but ennobles those that he willed to be small. That quote from Kepler is worth slogging through all that Latin that he did, all that scientific Latin, which is not so easy. So that's from his De Stella Nova of 1606. I think Kepler would say, now that's my scientific reception of Copernicus, okay? And it is a reception that only a truly competent astronomer of my time can give, because you have to understand what the universe really looks like to a careful observer. And that's it. So, thank you.